Hello guys, welcome to Rental Solutions. Welcome to your exam prep on grade 12 physical sciences for the topic momentum and impulse. The question paper that we are looking at today is the physical sciences paper 1 of the Eastern Cape province, written in June of 2024. Because this is a question paper, we are going to read instructions. We are not going to read all of them, but we're going to read just a few that you know we will use, but all of them are important. Okay, so please guys, do not confuse that some are not important. All of them are important. Okay, and equally so. All right, so let's begin. um Instruction number 7 says the formulae and substitutions must be shown in all calculations. Okay. And instruction number 8, give brief motivations, discussions, etc. where required. This one is key, guys, especially when you motivate, to give reasons for your answers. But relax, just say whatever that you want to say, as long as you link it to whatever the question is asking you. Instruction number 9, round off your final numerical answers to a minimum of 2 decimal places. This is physical sciences. You will be making substitutions, which when you calculate them, they will give you answers maybe to many decimal places. Now, if the step is not your final answer and you happen to have decimals, maybe round them off to 4 or 5 decimal places, and only your final answer should be to 2 decimal places. Okay. And of course, one instruction that I know you and I like so much is to write neatly and legibly. Guys, this is a challenge to say, let's improve our handwriting. Our handwriting should be neat and legible. People should be able to read our handwritings. Okay. So it's also one of those things that we should try to improve. Right. So without any waste of time, let's check this paper. This is a June exam, so we can't really say momentum will be in question 4. It can be in question 4, it can be question 5, but let's see in this particular question where it'll be. Question 2, here it's forces, and again question 3 is forces. Question 4 is vertical projectile motion. Now let's get to question 5. So here it is, question 5. All right, let's go. A truck of mass 1,500 kilograms, traveling at a constant speed of 20 meters per second to the west along a straight horizontal road, collides with a stationary car. Ooh, so a stationary car, it means velocity of the car is 0, of mass 900 kilograms, and the two vehicles moved together after the collision. The collision lasted for 0.2 seconds. Ignore effects of friction. Okay? Ignore effects of friction. Okay? Happy? All right. Now, 5.1. 5.1, what does it say? So 5.1, it says, explain what is meant by the term isolated system. So an isolated system is a system in which the net force is 0. Okay. System in which the net force is 0. System in which the net force is 0. Okay. So you see now, when they said we must improve our handwriting, write neatly and legibly, they were meaning this, guys. Okay. So this is a system in which the net force is 0. That's your isolated system. 5.2, state the principle of conservation of linear momentum in weight. So it says in an isolated system, okay, in an isolated system, total linear momentum is conserved. Total linear momentum is conserved. Total linear momentum is conserved. Right? Is conserved. Okay, guys? Perfect. Now let's see. 5.3, calculate the 5.3.1. 5.3.1, it says calculate the speed of the vehicles after the collision. You see, they're not saying velocity, they're saying speed. So whatever velocity vector we are getting, or whatever velocity value we will get, we should just ignore the direction and just state it as a speed. Okay? So 5.3.1, I will say the west is positive. Okay? So to the west is positive. Okay? Now, what do we say? M1V1 initial plus M2V2 initial equals M1 open bracket, by the way, M1 plus M2 close multiplied by V final. Okay, this is because they said after the collision the vehicles moved together. Okay, so what is mess 1? Perhaps let's call mess 1 the truck. So what is that? It is 1500, and what is its initial velocity? It's 20 meters per second to the west. What is mass 2? It is the car. Its mass is 900 kilograms. It is stationary, so its initial velocity is 0. So again, 1500 plus 900 multiplied by the final velocity. Okay, so 15 times 2 is is basically 30. So we expect, should we say 300? I think 300,000. Will 300,000? Nah, 30,000. 30,000. This is 30,000. Let me press my calculator. 1500 times 20, it's 30,000, correct? Plus 0 equals 1500 plus 900 will be 2400, isn't it? Is it 24, guys? I do not know. Yes, it's 24 V sub F. Okay, so 30,000 divided by 2,400, it will be 12,5, like a bag of maize meal. Okay, so now what is this? Maybe let me do this. 30,000 equals 2,400 V sub F. So we can therefore say V sub F equals 12,5 meters per second. Because they said speed, we don't have to care about the direction. So we're going to leave it there. Okay? Perfect. Now, 5.3.2. And by the way, guys, this question is 20 marks. So that means we must spend 20 minutes on it. Okay? We must spend 20 minutes on it. Okay? Perfect. Now, let's see. 5.3.2, calculate the net force exerted by the truck on the car. The net force exerted by the truck on the car. It's up to you which value you're using, right? So I'm going to use, again, I'm going to say west is positive. That's very important. West is positive. Okay, west is positive. And by the way, the speed that we got there, if we calculate, we refer to it rather as velocity. As you can see, it is positive. It is going to be west. So it's positive. Okay. Now, momentum impulse theorem. It's F net delta T equals, let me use this, M times V sub F minus V sub R. So which one are we looking at? We're going to look at, which vehicle should I? Okay, let me take the car. Okay, let me take the car. If I take the car, it'll be, but it doesn't matter. Force exerted by the truck on the car. I can take F sub net. What is the time? The collision lasted for 0.2 seconds. And then if you take in the car, you can say its mass is 1,500. And what is its velocity? Its velocity in final was 12,5. Its initial velocity was 20. Okay, was 20. Right? It was 20. Right? So here, guys, you need to be careful. You need to be careful of what your F net is really representing. The question is saying the net force exerted by the truck on the car. Okay, so this, when we use this value here, it'll be the net force exerted by the car on the truck. Okay, so this will be let's see, 0.2 F sub net is equal to 1500 multiplied by 7.5. So this is 11,215. Now this divided by 0.2, and by the way, it's minus, right? So what is this? This is 56,250 newtons. I forgot the minus there. The negative, it's negative 56,250. Okay. Now, we can therefore say the F net by the car is, of course, when you look at this, it'll be east, right? It'll be east. This will be the force that's exerted by this is the force exerted by the car on the truck. It'll be 5250 newtons east. Okay, east. This is the net force exerted by the car. However, the question is saying net force exerted by a truck on the car. So therefore, net force exerted by the truck on the car is 56,250 newtons west. Okay, remember the car, obviously action reaction, the car and the truck, it's action reaction. Okay, so here if you wanted to get this answer, you could have just used the value of the values for the car. Okay, perfect. Now 5.4, is the collision elastic or inelastic? Use relevant equations to explain. So we're gonna say E sub k equals half times mass times speed square. So now sum of the kinetic energy before collision. So I'm gonna say initial. What is it? It is half. The truck was 1,500 and the speed was 20 square, and the car was is 900 kilogram. It was stationary. So what is this? 0.5 times 1,500 times 20 squared. So what is this? This is 300 joules. This is 300 joules. Right? Now the sum of the kinetic energy after the collision is equal to, again, half the masses. Remember they were moving together. 1,500 plus 900 multiplied by bag of maize meal, 12,5. Ooh. Yeah, bag of maize meal is 12,5. One for the family, not for bachelors, guys. 12,5. Now this is 187,500 joules, correct? Now what you're seeing here, you can see that total kinetic energy before collision, okay, is not equal to total kinetic energy after collision. Therefore, the collision is inelastic because these two are not equal. Alright, collision is inelastic. Okay, perfect. Now 5.5, delicate equipment is usually packaged using bubble wrap for safety of the equipment. Explain how using this process keeps the equipment safe. So when we look at this, we are basically looking at the application of your impulse. Remember, where let me just write in red as a reminder. Remember, we say that F net is equal to delta P over delta T. The intention is F net, or rather, we know F net is directly proportional to change in momentum or impulse. The very same F net is inversely proportional to time. Okay, the smaller the change in momentum, the lower the force. The longer the time, the collision time, the lower the force of impact. Okay, now let's answer this question. So, why are bubble wraps used for the safety of delicate equipment? So, bubble wraps, I think I should write it. I will say bubble wraps create, um, let me say this. Bubble wraps have um, inflated, inflated um, surface that create, okay, that create, how should I put it? I'm gonna say that create a spacing, that create a spacing, that create a spacing um, that that ensures, okay, let me put it like this, that create a spacing that ensures the contact time, that ensures the contact time, the contact time between, okay, that ensures the contact time, um, okay, the contact time of the collision, yeah, the contact time of the collision of the equipment, at the contact time of the collision of the equipment and the container is, I'm gonna say, increased. Okay, I'm gonna say increased. Of course, it is increased, right? And this leads, to a reduced force of impact on the equipment. This leads to a reduced, this leads to a reduced force of impact. So this force of impact, if you like, I'm basically saying net force. Okay, force of impact, which is the net force on the equipment. Okay, on the equipment. Okay, on the equipment. Okay, guys, on the equipment. All right, on the equipment. So this is basically the gist of it. So the gist of it is this: bubble wraps create a spacing that ensure an increase in contact time of the collision. All right, did I even write that? Ensuring that the space ensures that the contact time of the equipment and the container, the contact time of the collision, Okay, so let me add this, perhaps with a red, uh, contact time of the collision, contact time of the collision between the equipment and the container is increased, and this leads to a reduced force of impact on the equipment. That's fine. Okay, so this is what bubble wraps are for. Okay, so what are you doing? The contact time between your container and the equipment is increased. When that contact time is increased, by virtue of using this relationship, when this time is increased, it means the net force is decreased, because net force is indirectly proportional to time. Okay, that is it. So this is it, guys. Remember, if you are looking for a tutor, you can visit our website. And of course, because you're watching this video on YouTube, please subscribe and like if this was really helpful for you. And of course, you can also follow us on your favorite social media platforms. Okay, with that being said, ours ends here. And by the way, the links to these platforms will be provided in the description of the video. So, bye bye.